Okay, 634 says, in a study of parasite-host relationships, 242 larvae of the moth were exposed to parasitation by the incumbent fly, and the following table shows the number of incumbent eggs found in each of the larvae. Okay, so it's kind of gross, but here it goes, and it says in 21 of the larvae, 0 eggs were found. In 77 of the larvae, 1 eggs were found. In 52 of the larvae, 2 eggs were found, so on and so forth. And in this case, there was actually 1 larva that was very unlucky and had 15 eggs in it. It's kind of gross. All right, but anyway, y bar in this case is 2.368. And maybe I shouldn't say gross. This is just nature. Okay, and s is equal to 1.950. Okay, and it says the student's t gave us a 95% confidence interval for the mean, for mu, which is the population mean number of eggs per larva, okay? And that's 2.12 less than 2.61, okay? And then it wants to know, part A says, does it appear reasonable to assume the population distribution of y is normal? Okay, so is y normal? Okay, and if you look at that table, you can see there's a heavy concentration in these low numbers. They're around 0, 1, 2, 3, or 4, and then anything beyond 5 and up, very, very small. Okay, so we're getting something large over here, and then very few, but it's possible to be out here. So we've got a long tail in this direction. Okay, so is y normal? No, it's heavily skewed. We've got a big tail, things like that. Okay, but then B says, is it appropriate, or it says, in view of your answer to part A, on what grounds can you defend the application of student's t method to this data? Okay, so even though it's not normal, okay, because we have 242 larvae, in our random sample of larvae, we have 242 larvae, and we counted all of the eggs in each one. N is very big. Okay, so even though it's not normal, N is very big, so the t distribution is acceptable to use. Okay, so we can still, because the t is big in this case, we can still make a 95% confidence interval, and it has meaning to us.